I want to do dichotomous data. I have error firm. I have non-error firm. Now, I need to be very careful how I say this. I got my data from CompuStat Accounting Research and from Audit Analytics for error firms. For people who don't know auditing, Audit Analytics provides most of the information. That's where you get it. It's by quarter. So what you'll see for error firms and all this information, they will tell you, let's say for a firm, that they committed an error, let's say in 2005 in this period. It's not by year, it's by quarter. So if you have a firm, let's say you're, give me an idea here, San Diego Gravel and Sand Company, I just made that up. You committed an accounting error. They identified you in the SAC. Audit Analytics will report that, and you committed it at this point in time. Okay? So therefore, you have to do a restatement on your statements. You have to go back in there and restate all your public information. Okay? So that information came that way. Okay? Now I need to say some other things here. The data has to be a little further here. Came over 6 years by quarter. 102 firms. Now, this is where data gets a little trickier. I have to omit some firms. If you're not a continuing entity over those 6 firms, you got kicked out. So no firm that could have partial years got existed. If you had more than one error in that firm, I kicked you out. If you had multiple companies with errors, I kicked you out. If you had sales under 500 million, I kicked you out for being too small. So there's a lot of firms in that category. The categories were defined by NAICS, not SIC code. Categories had to be defined too by the 4 NAIC code, so I had some definitions I had to define to because of what I was going to do. Because the goal I had as an auditor was this. I wanted to, because I have to perform analytic procedures. Because if I'm going to compare, and I want to compare pharmaceuticals, communications, mining, and something else, I have to compare like-kind companies. Okay, so I have to do some further mining down the line. Because I'm going to do a top-level analysis, then I want to be able to compare apples to apples, oranges to oranges, cherries to cherries, and baseball to baseball. Well, I got that one. Okay, so this is how I went through on this one. Okay, descriptive category came as follows here: financial, pharmaceutical, communications, mining, pretty evenly spread out. Yes, no companies. No means no error. Yes, errors. Broke down to by error, no error within categories. And it took a lot of work to do that, and I'm still not done because you got to go in there and find a like company with same sales. Then it was sales, then by asset. Ugh, sorry. To make sure you're comparing the same. There was no statistical difference between industries too, so we didn't have any what I call preponderance within an industry. And then I ran a logistic regression. That's where I'm comparing with. And I ran it, I hope I do this right. I ran a 2x2 table, which most of us in statistics and machine language would know is simple, straightforward. 0 to 0. Sorry I couldn't clean it up, but I couldn't make this table any bigger. 1 to 1. In logistic regression, I used SPSS, hit enter, straightforward type analysis. And it was able, on the 102 firms for accounting revenue, it hit 10 for error and 68 on the non-error. So logistic regression went pretty good on this one, on the non-error. I've got a lot more coming up here. So on logistic regression, SPSS, version 16, so that was pretty straightforward. For us statistics, this is where I started getting excited. Statistical significance was, take it back, Edward. Statistical significance was only occurring at this level here. GDP 3 years was 0.045. The rest were not statistically significant. And the way I calculated that was as follows. pretty straightforward. I went into the U.S. economic development, economic for NAA sector. If I had a sector that had 3 years before, let's say it was 103.000 of sales for that sector. 3 years later, it was, I'm going to say it was 103. I'm using this example. 3 years later, first year, I just divided the third year by the first year equals 100%. And that was my input variable. That way I got rid of big numbers in their triangulation, okay? So that's what that GDP indicates. So that indicated that the GDP 3 years was an important, statistically significant indicator. But nothing else stood out, as you can see there. So logistic regression, the whole model was statistically significant, by the way. Okay? But only one model came up statistically significant. And I used the enter command, and you know how that works in SPSS. It throws everything in and kicks out everything it doesn't need. Okay? So let's remember that. And then it was a positive correlation to 0.88, which wasn't a high number. For us statisticians, well, let's go back here. Let me tell you something, too. This number 2 was not a high number. For us statisticians, we want to see that number to be a big number, too. We don't want to see that number to be low. That means it didn't add to the final Y that much. Okay, the R squared, or 0.22, that's even getting some debate over at NIU, where I teach part-time, that even the R squared could be a debate, too, if that's really that important anymore. But that's a different story. I ran CART, and I have this number, too, ties up with the rest of this. And then here's what I got. And I do the pace print, so bear with me, okay? I ran it using 1-1 on the test, learn and test. I want to always look. This is a supervised model, as you all know. I want to learn it, and then I want to test it. And I always want to look at tests first to see what's going on with this baby. And I've got, in this model, 20 out of 29, which at first I thought, nah. But no, it's actually pretty good. And I'm going to show you later on how this works out. So this model gave me 20 out of 29. I got on 0 here. Hope I can do this right. It did 60 out of 73 on 0, which was pretty good. And then here's my lift on this. As you can see, it predicted the 29. Hope I can do this right here. On this level here is the 29 that it's trying to predict. 1 plus 10 plus 5 plus 13 is 29, which is 29 the error firms. I'm getting a lift coming up the line here. This is my false positive to the true positive there. And the way I always look at it is your false positive is like your type 1 error to the total. So we're getting a pretty good number here. You know what I mean? If it was 50-50 down the line, that means I could flip a coin, and that would be the result. As you can see this baby graphically, it's pretty nice. I like it. As you can see this baby come up the line here. The way I read CART, and I grant you, I've never taken a CART training program. This is 29 of my error. That's all my error. Right. Yeah, I got some charts coming up. Because one of the things I get asked is, why do I, as an accountant, when I go out to my customers, I'm used to logistic regression. Why do you use CART, Ed? Well, I'm going to show you. Okay? I tell my customer, that's a nice chart. Okay, so, okay. Here we go. This tells me something that logistic doesn't tell me.